Engines! They are the marvels of modern engineering, the powerhouses that keep our world moving. They're the beating heart of everything from your granny's little hatchback to massive cargo ships that traverse the oceans carrying goods across continents. But have you ever stopped to think about what makes them tick? What is the secret behind their relentless power and efficiency? What actually makes the power? What transforms fuel into the energy that propels these machines forward? I'm not talking about petrol or diesel, the stuff you fill them up with. No, it's something far more intricate and fascinating. I'm talking about the clever bit that makes it all go bang. The ignition process, the very heart of the engine's operation. That, my friends, is ignition. The spark that breathes life into the engine, setting everything in motion. We're talking controlled explosions here. The kind that make your car move instead of just sitting there looking pretty. It's a symphony of power and precision. And there are two main ways to make this magic happen. Spark ignition and compression ignition, each with its own unique method of creating power. One uses a little spark, like a miniature bolt of lightning, igniting the fuel-air mixture with precision. The other, it's all about squeezing the air and fuel until they spontaneously combust. A marvel of engineering that relies on pressure and heat. Yes, you heard that right. Spontaneous combustion. Why should you care? Because understanding this can change how you see every vehicle you encounter. Well, understanding the difference between these two methods is like knowing the difference between a thoroughbred racehorse and a trusty old tractor. Each has its own strengths and purposes. Both will get you from A to B, but in very different ways. The racehorse is all about speed and agility, while the tractor is about strength and endurance. So buckle up, petrol heads, because we're about to delve into the fascinating world of engine ignition. Prepare to be amazed by the science and engineering behind it all. Get ready for sparks, compression, and a whole lot of power. This is where the magic happens, and it's going to be an exhilarating ride. Let's start with the one that's probably more familiar to most of you, spark ignition. This is the type of engine that has been powering our vehicles and machines for over a century. It's the engine you'll find in most petrol cars, motorcycles, and even your lawnmower. These engines are everywhere, from the vehicles we drive to the tools we use in our gardens. Imagine a tiny explosion in a bottle. That's basically what's happening inside a spark ignition engine, hundreds of times per minute. This rapid series of controlled explosions is what generates the power to move your vehicle. You've got a cylinder, which is like the bottle, and inside you've got a mixture of air and fuel, ready to go boom. This mixture is carefully calibrated to ensure optimal performance and efficiency, but here's the clever bit. The timing and precision of these explosions are crucial for the engine's performance. A spark plug, a little device that looks a bit like a miniature threaded bolt with an electrode sticking out, creates a spark. This spark is the catalyst that ignites the fuel-air mixture. This spark ignites the fuel-air mixture, causing a mini explosion that pushes a piston down. The movement of the piston is what ultimately drives the engine. This piston is connected to a crankshaft, which in turn spins the wheels of your car. Simple, right? This process is repeated in a continuous cycle, providing the power needed to keep your car moving. Spark ignition engines are known for their responsiveness, which is why they're great for zippy city cars and high-revving sports cars. Their ability to quickly deliver power makes them ideal for a variety of driving conditions. They're also relatively simple and cheap to manufacture, which is why they're so common. The widespread availability of these engines has made them a staple in the automotive industry. But like a hot-headed teenager, they can be a bit thirsty for fuel and not always the most environmentally friendly. Their high fuel consumption and emissions are significant drawbacks, but hey, nobody's perfect, right? Despite their flaws, spark ignition engines have been a reliable and essential part of our lives for decades. Now, let's talk about the big boys, the engines that power lorries, ships, and even some cars. These engines are the workhorses of the transportation world, moving goods and people across vast distances with remarkable efficiency. These behemoths rely on a different kind of magic compression ignition. Unlike the spark ignition engines found in most cars, diesel engines use a unique process to get things moving. Instead of a spark, these engines use the sheer force of pressure to ignite the fuel. This method is both powerful and efficient, making it ideal for heavy-duty applications. It's like trying to light a fire by rubbing two sticks together, but on a much smaller and more violent scale. Here's how it works. Imagine the intense friction and heat generated by rubbing sticks. Now multiply that by 1,000. Air is drawn into the cylinder and compressed to an insanely high pressure. This compression is so intense that it heats the air to a very high temperature. We're talking about squeezing it down to a fraction of its original volume. The piston moves up, reducing the space inside the cylinder and increasing the pressure dramatically. This compression generates a lot of heat, so much heat that when fuel is injected into the cylinder, it ignites spontaneously. Boom! The result is a powerful explosion that drives the piston down, creating the engine's power stroke. Compression ignition engines, often called diesel engines, are known for their incredible torque, which is a fancy word for pulling power. This makes them perfect for tasks that require a lot of strength, like hauling heavy loads. They're also more fuel efficient than their spark ignition cousins, which is why you often find them in vehicles that need to haul heavy loads or cover long distances. Their efficiency means they can go further on a tank of fuel, saving money and reducing the need for frequent refueling stops, but they're not without their downsides. Diesel engines can be quite noisy, producing a distinctive clatter that some people find unpleasant. They can be noisy, smelly, and produce more emissions than spark ignition engines. These emissions include particulates and nitrogen oxides, which can contribute to air pollution and health problems. But hey, you can't have it all, can you? Despite their drawbacks, diesel engines remain a crucial part of our transportation infrastructure, providing the power and efficiency needed to keep the world moving.